Okay, everyone. Let's talk about Chapter 3, Math 107 MATC content, practice test, Chapter 3. Again, this is for, these are made for anybody, whether in the course or not. I mean, the mathematics is the mathematics, and some pretty interesting content that they have in this particular course that's useful in many circumstances. So it's good for us to know that. They've got 10 questions here. I'm not always, I don't know what the circumstances are. I frequently am doing quite a bit of the questions. We don't necessarily have to do every one of them. Probably we have to do the hardest at least, and ones that are representative of what's going on. But let's see how it proceeds. It shouldn't be too bad. Here, like I said, in the past, we've talked about different things. We're going to talk about different things here as well, you guys. They've got a particular, for question 1 here, they say solve a particular proportion. Before we do so, let me, there's perhaps a couple things we should maybe say up front, I guess, when we're doing various things, to find out, just to have it in the back of our mind and have it in our back pocket, I guess, to say, so you could say, before we do anything like that. If two fractions are equal to one another, let's put it that way. If two fractions are equal to one another, what can happen is you can multiply by b on each side, and you got this, and then multiply by d on each side, and you have this. So basically, well, let's do it again. You start here. You say, okay, I'm saying two fractions are equal to one another. If two fractions are equal to one another, you can multiply by b on each side and get this. Then multiply by d on each side and get this. At the end of the day, there's the implication that AD equals BC, which is the same as what they call cross multiplication. You could just say, okay, this is not cross cancellation of fractions, where, hey, I'm multiplying two fractions, and there is somehow a number that can go to a denominator or into a numerator, and things can cancel out. That's cancellation. That's not what this is. This is cross multiplication. And basically, the justification for this nice-looking trick is the mathematics that I just showed you that got you to here. So this, you go A times D, and that's the same as B times C. Here it is, A times D is equal to B times C. We proved that right here, just wrote it a little differently, and that's why the cross multiplication works. There is also some stuff that gets said. Frequently in mathematics, it's good to be able to translate stuff. When they say what means some variable, x or y or z or n, etc. What means some variable, some unknown? Of frequently means multiply. Is means equals. Rather interesting. 35% cent is a penny. How many pennies in a dollar? It's 100 pennies in a dollar, 100 cents in a dollar. How many years in a century? 100 years in a century. So percent is per 100. 35% means 35 per century, per 100. If you divide by 100, it moves 2 places. So if you lose the percent symbol and move the decimal place over 2 places to the left, you got 0.35. If you take 0.35 and move the decimal point 2 places to the right this time and tack on a percent, you got percent. So there's more to it than this, guys, but basically percent means per century, and there's a lot you can do here. Well, you're dividing by 100, percent. 30, lose the percent notation when you're here. Percent means per 100. 35 over 100 is 0.35. If you take 0.35 and move 2 places over to the right, put a percent on it, you got percent. If you get rid of the percent notation and go 2 places over to the left, you got the 0.35. So it's pretty neat in that regard. There are some other things of interest. You could say that the amount of interest accrued is the amount of principal invested, the rate at which you invested it, and the time in years. This is the rate in years, then you got to convert time in years, and this will tell you how much interest you get. That's just simple interest. So if you want to know what the amount is that you have to pay back, or the amount that the bank has to pay you, it's the initial investment plus the interest that you got. And this is for simple interest right here. And that's simple interest. It's a more complicated, that's simple interest. So it's a more complicated situation if you're talking about compound interest. And compound interest is a situation, let me see what we want to get rid of here. I don't want to get, honestly, I don't like to get rid of any of this, but okay, I forget that we also have a film here, and we can always go back, so that's always good. Regarding simple interest, for compound interest, there's a couple different ways it gets looked at. Let me kind of give you a strict way of looking at it, and there's some beautiful mathematics that discusses why this is true. That right now is none of our business, but let's say something here. The amount of interest accrued that you'll the total amount that you'll have to pay back, or that the bank has to pay you back, the investors have to pay you back, is basically given by a formula like this. P is the initial investment, the principal, and this multiplied by 1 plus R over N to the NT. A is final amount. P is principal. Principal investment. Let me just see how my spelling is not the greatest, guys. I don't think we're going to, let's see here, the principal. Initial investment or principal. Let's see how that, I'm sure how that gets spelled, guys. Let's say the initial investment, let's put it that way, so it's a little easier. They call it principal. I'm just not confident how I'm spelling it, so I don't want to put it down there like that. Initial amount or investment. N is number of times it is compounded per year. Number of compoundings per year. N is the number of compoundings per year. And R is the rate of investment, non-decimal. Either the bank's investing in you, or you're investing in the bank, or in the borrower. The borrower is investing in you. Rate of investment, non-percent. You got to get a straight out decimal to get this. And T is number of years. So pretty fascinating stuff, guys. The mathematics behind it is quite beautiful. Much of the mathematics behind the compound interest scheme centers around that amazing number, e, the base of the natural logarithms. We're not going into that right here, not really the place of the discussion, but the base of the natural logarithms, e, plays a big role in the mathematics pertaining to this. So, it's a big role. It's pretty fascinating stuff, you guys. And we got this. Like I said, it's eventually, I'm going to take this off eventually as well, but we got that. It's a lot easier with the simple interest. The compound interest is, you know, can get a little rough. But it's not convinced that it's difficult, because it's not. Compound interest here, simple interest is quite a bit more simple as well. All right, guys, some stuff to kind of look at. I think we can turn around and take care of this thing. Let's we probably hit all 10 problems, I think, when we're doing this. All right, you do have this. Again, ALEKS, when you're doing this, its system itself also shows you a lot of what to do. Even within the system itself, it shows you quite a bit of what to do. So that's pretty interesting in its own right, pretty helpful. If we draw a blank for some reason, we're going to do something. So looking at this, like I said, I don't have a calculator on me right now, but we're just going to look at the answers, how they get to do the setup, and we can always check that with our calculators at our convenience. Let's at least have the mathematical logic present that we need. Let's have the mathematical logic present that we indeed need to be able to solve all these problems, guys. The calculator is not a big deal. You pull out a calculator, as long as you know what you're doing with the calculator, what you're supposed to be doing with the calculator, that's what matters. To do that, you got to know how you actually solve the problems. What is the logic behind these problems? So that's more our concern than just about anything else. More so than just plugging in numbers. Let's see the logic as to why something is true. Having said that, just kind of go down the line with the stuff we know, and let's just try to give the answers. In a very logical, really well-explained manner. They want you to round your answer to the nearest tenth for this particular problem. I am taking two fractions which are equal to each other, and we can do cross multiplication for that. 5 times v is equal to 4 times 17. 5 times v is equal to 68. Divide by 5 on each side, and we're here. V is equal to, 5 goes into here. It's a good question in its own right. 5 goes into 68 13 times, with 3 left over. And there we go. And that's number 1, you guys. Number 2, solve for x. Kind of the same sort of argument going on here. They got 4 over 5 equals x minus 2 over 10. When I see something a little bit convoluted like this, and there's nothing else going on outside of it, I just put the quantity x minus 2, I put it as an actual quantity. The quantity x minus 2 written as a quantity is indeed the quantity x minus 2. Put it in parentheses like that and then go for it. From here, you'll do the mathematics. You do cross multiplication, as we've already talked about. You end up getting, let's go, 5 times this quantity. That should be of interest. And the other one is 4 times 10. Okay. Well, we know a lot of things here. So let's just do a lot of things. 5 times x is 5x. 5 times 2 is 10. 4 times 10 is 40. Minus 10 is the same as plus a negative 10. We've been down this road before. So we're here. Well, this is not really going to be a real difficult matter for us to do. let's add a positive 10 on each side, as we've done in the past. Similar kind of arguments as the past, we get this. Divide by 5 on each side, a positive 5 on each side, and you get 10. And there you go. And x is equal to 10. So that is problem 2. Problem 3, on the blueprint of a house. And again, all this scrolls at the end, folks, so you can kind of just look at it as well, and the problem should be there. Let me just say, hopefully we're all agreeing with the answers that are given. If I think we did it right, so if they have something different, they might have written something wrong here for us when we did it. We're looking okay. Yeah, it looks okay so far. So, so what do we got going on here, guys? For problem number 3, question number 3, on the blueprint of a house, question 3, let's say problem 3. On the blueprint of a house, 48 millimeters represents 9 meters. The length of the living room is 32 millimeters on the blueprint. What is the actual length of the living room? All right, guys, there's a number of ways you can do it. You're going to get the same answer each time. We might want to just look at it. There's a real number of ways you can look at this, and you always get the same answer. As long as your mathematical logic is sound, you're going to get the right answer. Let's take a look. On the blueprint of a house, 48 millimeters represents 9 meters. So 9 meters for every 48 millimeters. The length of the living room is 32 millimeters on the blueprint. What is the actual length of the room? So I'm going meters to millimeters, meters, real length, to millimeters on the blueprint, real length, meters, millimeters on the blueprint. Meters to millimeters, meters to millimeters. Or flip it. If you flip this, it's millimeters to meters. You got to flip this as well. If this is going to be meters to millimeters, then it's got to be meters up here and millimeters over here. If you want to flip this, feel free to do so. 48 over 9. If it's millimeters on top, meters on the bottom, the same thing has to happen here. 32 millimeters, x meters. Millimeters have to be on top, meters on the bottom. It's as simple as that. You also could say, hey, look, the long length is 48 millimeters. The short length is 32 millimeters. The house itself has got to be less than 9 because it's 30, or at least the length of the room, the dimensions have to be less than 9 because 32 is less than 48. 48 pertains to 9 meters, 32 pertains to x meters. You could do it like this just as well. Say, wow, it looks a lot different. You sure it's going to be the same answer? Absolutely. If you look at it, if you put the 9 and the 48 right here, 9 over 48, and the x over 32 right here, let's go for it. I mean, let's go here, and let's see if something can happen here. 48 times x. 48 times x equals 9 times 32. I may not want to multiply it out yet. I just want to kind of look at where it's at. Well, I got this right from this one. Right from this one I got it. I got it right there. Got that. True. From this guy, let's have a look. You know, millimeters and millimeters cancel out. Meters and meters cancel out. Let's go. You know, here you saw what happened. And here you saw what happened. Okay. Well, look at this. That's 48 times x. That's 9 times 32. Wait a minute. What are you talking about? That's 48 times x. And the other one's 9 times 32. It doesn't matter how you're approaching this stuff, guys. You're going to get the right answer if your mathematics is sound. Well, there it is. It's going to have to be, you know, there it is. I'm going to solve this. Well, I'll tell you what I'm going to do. I got 48x equals 9 times 32. I'm going to divide by 48 on each side. I got 9 right here. This right here, 32, huh? That's 2 times 16. 48, that's 3 times 16. Maybe there's something here. You know where I'm going, guys. You know where I'm going. Cancel these out. I got x equals 9 times 2/3. Well, the 3 cancels into the 9 3 times. 3 times 2 is 6. 6 meters at the end of the day. Right? I mean, the way the 9 is, you know, you could play this a bunch of ways, but 9 is 9. 9 is the same as 9 over 1. The 3 goes into the 9 3 times. 3 times 2 is 6. It's 6 over 1. It's just 6. So that is 3. Here they talk about using some language here to get this thing under control for number 4. So what do we have here? For number 4, follow the instructions below. Rewrite the percentage in the sentence below as a decimal. Last year, 4% of the used cars they sold had over 30,000 miles. 4% of the used cars is 4 per 100, 4 per century. That's pretty easy. So we're okay for that particular problem. We got it looking like that. Okay. That's A. So I'm kind of running around with the chalk a little bit here, guys. For B, rewrite the decimal in the sentence below as a percent. The model was 0.347 of the size the original was. The model was 0.347 of the size that the original was. Take a walk 2 places to the right and tack on the percent. There's a number of ways you can play this one actually to get it to there. A little more complicated way would be, you know, saying tenths, hundredths, thousandths. This is 347 thousandths. And, you know, you could say, well, I don't know, I'd like to get this thing, you know, I'd like to see a way I could maybe write this in a different manner. Well, you could say, as it's kind of, I don't know that I even advise this, but I would say 34.7 times 10, 100 times 10. When you cancel out, you got 34.7 over 100. 34.7 over 100 is 34.7%. So number 4 kind of can play out that way too. That's number 4. Number 5. And let me just get some of this stuff out of the way here. Okay, for number 5, a chemist is using 389 milliliters of a solution of acid and water. If 19.2% of the solution is acid, probably in terms of volume now, guys, that's kind of the assumption here. A chemist is using 389 millimeters of a solution of acid and water. So 389 millimeters of milliliters. 389 milliliters of a solution of acid and water. Altogether, it's 389 milliliters. If 19.2% of the solution is acid, by volume is the assumption here, how many milliliters of acid are there? Round your answer to the 10th. The amount that is acid is unknown. What is 19.2% of, means multiply, 389. Percents are useful to visualize a problem. They're practically useless to solve a problem. You need to convert them to an equivalent fraction or to an equivalent decimal. That's the best way to go. There's other ways to do it, but usually equivalent decimal, equivalent fraction is what you're looking at. You're looking at that right there. Again, I don't have the calculator on me, guys, but that's the setup. That's what's going to get you there. So let's go how they gave the answer. And again, it is supposed that they are rounding this stuff. Round your answer to the nearest 10th. 74.7 milliliters. That right there . Okay, sounds good. Answer the following questions. And again, it's the same kind of argument happening here, folks, with number 6. They're saying for A and B here. They're saying, you know, what percent of 75.5, what percent of 75.5 is 81.54? What percent of 75.5 is 81.54? Well, that's 75 point, you know, what percent of, what is unknown, of means times, is means equal. What percent of 75.5, what percent of 75.5 is 81.54? Well, I mean, let's just put the number out in front just to make it a little more aesthetically appealing to what we're trying to do here. Divide by 75.5 on each side. This right here is going to give you some kind of a decimal answer. When you do get the decimal answer, you're just going to walk over. You're going to walk over to the right. Forgive me, you're going to walk, yeah, right. When you get a decimal answer, you're going to walk over to the right and see what we got here. So it's going to be, you're going to get somewhere in the ballpark. I mean, I don't have the calculator again, guys, but that's not, the main thing is get to here and then know how to use the calculator, which everybody knows how to do. I mean, you get this divided by this is about 1.08 at least. And if you want to make this into a percent, 1.08 is, in terms of percent, this right here. %. So that's kind of neat. Okay, so we got that. So for forgive me, not for 7. That's 6A rather. For 6B, you know, similar similar type of argument happens. You'd say, what number, here's a little different story here. What number is 46% of 18.5, right? So what number is, what number, I don't know. That's why I'm calling it x. Is means equal. What number is 46% of, means multiply, of 18.5? When you do that, you get 8.51. How stuff gets talked about. So that's pretty interesting, how that plays out, guys. Let's see here where I'm at. Right, exactly. For 7, let's see how they're going to talk about this for number 7 now. For 7, the next model, the next model of a sports car will cost 12.8% more than the current model. The current model costs $42,000. How much will the price increase in dollars? What will be the price of the next model? Well, the increase in, this is the amount of increase in price. Let's say X is the amount of increase. X equals the amount of increase in price. It's going to be 12.8% of what it currently costs. And the current model costs $40. It's the amount of increase. If it was, it'd be nice if they're going to give it to us for 12.8% of what it costs now. For the new model being 12.8% of that, it'd be great. It doesn't work that way. They're going to give us an increase in the price. The current price is $42,000. The increase in price, X, is 12.8% of the current price, which is going to come out 0.128 times 42,000. X is going to be, so what are they asking here? The increase in the price. So X is going to be the increase in the price. So the first one's going to be X, the increase in the price. And then and then later on, I'll tell you what's the increase in the model here. Well, what we got here is it's a lot of money. I mean, what it comes out to is $5,376. 5,300. Let me see here. Right, $5,376. We just do the math and we'll get that. And so $5,376 for that, and the price of the new one is, you know, let's say it's the price now plus the amount of the increase you're going to put on it. It's going to be $42,000 plus the $5,376. You know, that's the new price. And, you know, we add them up here and we end up getting $47,376. Yeah, it's for real. I mean, they up the price. So this is the increase, this is the amount of the increase, and this is the new price associated with what's going on right here, with this right here. And it's going to be, as I said, it's going to come out to $47,376. $47,376, absolutely. So that's number 7. Let's go to Let's go to 8. Question number 8. An item is regularly priced. An item is regularly priced at $88. It is on sale for 80% off the regular price. Use a calculator to find the sale price. All right, well, a number of ways to go there. Might as well, sooner or later, we got to erase some of this stuff, so let's just do it. Okay, as they said, guys, so let's do some of this. So let's look at number 8. For number 8, you guys, an item regularly priced at $88 is on sale for 80% off the regular price. Use a calculator to find the sales price. Well, I mean, the amount of the discount is pretty big. The amount of the discount is 80% off. It's 80%. 80% of the $88 is going to be taken off. 80% of that's going to be taken. This one's going to be taken off. So, I mean, that's just going to be 0.80 times 88. There's a number of ways you can play this. You look at this, and like I said, there's a number of ways you can do this. Let me cut to the chase a little bit on it when I do it. Let me kind of do a little bit in my head here when I do this. 0.4 short of that. Let me. It's going to be 17.6 times 4. 2.4, it's going to be 70. Again, great time not to have a calculator, right, guys? So let me just say this, and we can maybe talk about it a little more in a second. I am thinking that is looking. Let me be sure of that when I do this. I'm basically taking 0.8 times 88, right? That's this, so let's get down to business. Yeah, 64, they're here, 64 at 70, yeah, okay. Not quite, okay. So this is it. That should be it. That's the amount of the discount. That's the amount of the discount, you guys. What's the new price? Well, the new price is the original price, 88.00, or just 88, minus 70.40, which is equal to, at the end of the day on this whole thing, right, it's going to be 1760. And I did say 1760 earlier. If I multiply 1760 by 4, I do get 70.40. That's what I should have gotten right off the bat. I got it wrong. But this is the new price. That's the new price. There's a number of ways you can play this, guys. I mean, depending how athletic we are with these manipulations. And the more that we do this, the better that we get at doing this stuff, the better we are going to be at it. You could say, hey, look, If 80% is taken off, that means 20% remains. If 80% is taken off, then 20% remains. 80% of the price is gone, leaving 20% of the price. 20% of that price is what you're going to pay. 80% of that price is gone, 20% of that price is what you're going to pay. And that's just going to be, you know, take a walk, and you got, that's 0.20 times 88. Same as 0.2 times 88. Pretend it's 2 times 88. It's 176. And then go 1 decimal place over. There's a number of ways you can play it, guys. You could have gone right to the chase and said, well, 80% of the original cost is what I'm going to pay. 80% of the original cost is getting taken off. Only 20% is what I'm going to pay. It's pretty good. It's a pretty good deal, actually. So that's what you're looking at there for number 8. For number 9, it comes into some of the stuff we did earlier. Let me just get a little more chalk here, guys. Suppose Tom borrows $7,500. That's the principal. Now, who's investing? Tom or the people who are giving him the money? Well, they're investing in him right now to get the money back to them plus whatever interest they're going to make. That's how it works. Suppose Tom borrows $7,500 at an interest rate of 7%. Suppose Tom borrows $7,500 at an interest rate of 7%, compounded each year, once a year, in other words. Assume that payments are made on the loan. Assume that no payments are made on the loan. So in other words, the person is not going to make any payments on the loan until, I guess, they choose to do so. Let's just see what the person owes after a year. Let's see what the person owes after 2 years, is what they're asking. It's A and B here for number 9. So suppose Tom borrows $7,500 at an interest rate of 7%, compounded each year, once per year. Assume that no payments are made on the loan. A and B. Find the amount owed at the end of 1 year. Find the amount owed at the end of 2 years. Now, this person's not going to pay anything. Eventually, they're going to pay, I'm assuming, but for the sake of the mathematical problem, no payment has been made after 1 year, nor has any payment been made after 2 years. So what's going on here? Well, I mean, yeah, we know a lot, and we're going to say a lot. We know that at the end of the day, we got A is going to be P, the principal, 1 plus R over N, NT. Let's look at the A scenario, let's look at the B scenario, but this is definitely the operative words here. For A, find the amount owed. Well, okay. A is going to be $7,500 is what he did. 1 is 1. R has to be converted to a non-decimal. It's got to be a non-decimal. It's 7%. The rate is 7%, compounded yearly. Compounded each year. 7% is 0.07. You can't put the percent in there. It's going to be a problem if you do. N number of compoundings per year. That's done once a year. Once per year, the compoundings take place, and we want the 1 year scenario for this one to get what the person did. For the B scenario, they want to know what happens after 2 years. It's a different dynamic. It is once again, it's 7,500, nothing changing there. The mathematics is identical, the specifics are going to be different. This is 0.07. Number of compoundings per year is 1. Year is 1, and how many years? It's 1 compounding per year for 2 years. So 1 times 1 right here, 1 power, 1 times 2 right here is going to be to the 2 power. So what with that in mind, you know, 1 times 1 to the 1 power. Well, to the 1 power, you can just leave it like that. 1 times 2 is to the 2 power. That's a little different. So you're going to get a different answer. This is going to be a bigger number because it's not with that, and they're both bigger than 1, so it's going to be a bigger number, which makes sense. After 2 years, he's going to owe more money because he's holding on. He's delayed that long, so it's going to cost more, and that makes sense. So there's 2 different numbers you're going to get here. That should be interesting, how that plays out. And they're saying here, you know, let's find the amount. Follow the instructions below. Do not do any rounding. Okay, I find it hard to believe you're not going to do some rounding on this, but maybe not. Maybe, I guess you don't, because the numbers are pretty benign, I guess you could say. So how does this play out? All right. Look, at the end of that one, he did choose to pay it off. This is what he would owe. And this is what he owes anyway, but he said, you know, if he's going to pay it off or not pay it off. That's the end of 1 year if you do mathematics. Here, it's the exact same thing as here, but there's another 1 plus 0.07 over 1. Over there, there's another one here. It's to the 2 power. It's not in the first one, because it was just after 1 year period of time. But for this guy over here, it's this now. For the first one, it wasn't. I mean, you're done. I mean, the first one is just this, and you got this. The other one's going to be a little bit more. And it comes out to $8,586. Of course, it's going to be longer. You don't keep holding off on a loan and then pay less money for it. It'd be nice if it worked that way, but it doesn't. So some pretty fascinating stuff, how it all works. Let's go to 10. Okay, it's hard to see if I can read this stuff here, guys. All right. All right, here we go. Okay, now, this is number 10. A bank offers an investment account with an annual interest rate of 1.15% compounded annually per year. Rita invests $3,400 into the account for 2 years. Answer the questions below. Do not round any intermediate computations and round your final answers to the nearest cent. I think anybody who's ever had me as a teacher tells them never to, you've heard me tell you whether it's wherever I am, wherever I've taught guys, I'm telling you guys always don't be looking to round unless they tell you, and intermediate steps should never be rounded. Unless told otherwise somehow. Usually that's not going to happen. Don't be rounding your intermediate steps. Do not round any intermediate computations and round your final answers to the nearest cent. Reasonable. 10A and B. Assuming no withdrawals are made, how much money is in Rita's account after 2 years? How much interest is earned on Rita's investment after 2 years? Interesting question. Not too difficult either to look at. Let's see how we want to talk about it. Let me, since it's so similar, guys, I'm going to put number 10 right here. And then we're going to talk a little bit. All right. So basically, guys, what's going on here? Assuming no withdrawals are made, how much money is in Rita's account after 2 years? A is going to be the principal, which is it's just the same equation, guys. $3,400 here. Same general equation, right? She invested 1.15% compounded annually. So that is 1.15, 1 over 2 over, compounded annually. Number of compoundings per year is n. Well, this is compounded annually per year. And she's, again, number of compoundings, 1, and it's going to happen for 2 years. And that's what we're looking at. Obviously, you're doing what's in parentheses. Well, let me say something. I didn't say it for the last one. I might as well say it here. So here you go. You got this thing set up. 1 times 2, that's 2. I'm not saying anything very profound. But maybe this is a little more profound, hopefully. The only thing you're exponentiating is the parentheses quantity, not this. Don't multiply all of this. Do not multiply all of this. Do not multiply all of this and then square the result of that multiplication of all of that. One more time. Do not multiply these two and then square it. You're squaring just that. I've got all the different colors chalk. I'm going to take advantage of it. This is the only thing you're taking to the second power. This right here. Done, multiply by that. It's the same exact way you do problem number 9. Do not be exponentiating anything. Do not be exponentiating anything except for the item that is in parentheses. Solve what's in parentheses and then do the exponentiation. When you're done, multiply it by, earlier it was the 7,500 for problem number 9. For this one, it's the 3,400. Watch out for that. One of those do's and don'ts, I guess you could say. So this is where we're at. When we do this and how much interest is earned on Rita's investment after 2 years. Well, let's find out how much money she made. Well, let's find out how much money's in the account, and then we kind of just figure out how much interest was earned from it. So we're talking about, well, yeah, it's not a tremendous amount of money. It's not a tremendous amount of, you need a lot of money to, you could say, and so there's not a tremendous amount of money, but she still made money. She made, at the end of the day here, guys, $3,478.65, and there's your answer. And there's the answer, guys. So that's what she didn't make that. This is the amount she has. She didn't make that. She made the difference, actually, the amount of interest. So she invested $3,400 initially, and she has $378.65 at the end of 2 years. So what did she make in interest? The amount she made in interest is the amount she has minus the principal that she had invested. This is the amount she has after the investment was completed, at least after 2 years completion. This is the amount she has there, and initially invested $3,400. The difference between the two is the interest she made, and that's $78.05. So, yeah, I mean, she did not make a tremendous amount of money. So she made some money there. $78.65. Okay, that is some of the practice related to Chapter 3. And again, Alex has a lot of coverage of this. Whatever, it depends what course you're in, or if you're just looking at this for some of the personal enrichment. I mean, there's some really good problems that they have here, guys. Again, thank you all for your time, and we'll talk soon.